Hello students, welcome to class 11 physics. In this video we are going to solve numericals of the textbook exercise of chapter 5 laws of motion. Numerical number 15. Two bodies of masses 10 kg and 20 kg respectively kept on a smooth horizontal surface are tied to ends of a light string. A horizontal force F equals to 600 Newton is applied to A and B along the direction of the string. What is the tension in the string in each case? So as you can see over here, there are two masses M1 and M2. They are tied with the help of a string and force is applied in this direction on both the masses. Here M1 equals to 10 kg, M2 equals to 20 kg and F equals to 600 Newton. So first of all we need to find the tension produced. So let tension in the string be T. For motion of A, M1A equals to T. Because here for object A, tension is in this direction as well as force is in this direction. So M1A equals to T. For motion of B, force applied is in this direction and tension is in this direction, opposite direction. So for motion of B, we can write here force is in positive direction, so we can write F plus minus tension is in opposite direction, so we can write minus T equals to the external force, that is M2A, that is for the motion of the object B. So here F minus T equals to M2A. So equation 1 is M1A equals to T, equation 2 is M2A equals to F minus T. Now by taking the ratios of 2 and 1, left hand side of these two equation becomes M2A upon M1A. A gets cancelled, so we have M2 upon M1 equals to F minus T upon T. So separating this term we get F by T minus T by T, that is F by T minus 1. Now substituting the values of M2, M1 and F. So we get 20 by 10 plus 1 equals to 600T, because in this equation we got M2 upon M1. Here from this equation taking minus on the left hand side, so it will be F upon T. So 30 by 10 equals to 600 by T, therefore T equals to 200 Newton. Now when force is applied on lighter object M1, now here we are considering force in this direction. So let tension in the string be T dash. Motion of A now becomes F minus T dash equals to M1A, and motion of B becomes M2A equals to T dash. So by taking the ratios of 2 and 1, we get M1 upon M2 equals to F upon T dash minus 1. Taking this minus on this side, it becomes plus 1. So 10 upon 20 plus 1 equals to F upon T dash. So 30 by 20 equals to 600 upon T dash. So T dash equals to 400 Newton. So this is the tension in the string in each case. So students, you may copy down this numerical. Now numerical number 16. Two masses 8 kg and 12 kg are connected at the two ends of a light inextensible string that goes over a frictionless pulley. Find the acceleration of the masses and the tension in the string when the masses are released. So here we are having two masses, m1 equals to 8 kg, m2 equals to 12 kg. Let tension in the string be T. Here, as you can see the free body diagram, where here the two masses are connected via the string and tension is always towards the rigid support. So for this case it is in upward direction. Acceleration over here for mass m1, it is in upward direction because the object will be moving in the upward direction due to light weight. On the other hand, mass m2 will be going in downward direction, so acceleration will be in downward direction. Let common acceleration of system is A. Acceleration of m1 is in upward direction, acceleration of m2 is in downward direction. Equation of motion of m1, it becomes T minus m1g equals to m1e, because as you can see over here in this figure, tension is in upward direction, m1g is in downward direction. So upward direction is taken as positive, so T plus minus m1g, that is equals to the force exerted on the mass, that is m1a. Now equation of motion on m2. Here m2g is in downward direction and tension is in upward direction. Here we have taken m2g equals to m2g minus t equals to m2a, that is the force on object having mass m2, that is m2a, and it is equals to m2g minus t. Now adding these two equations, we get, first of all, adding the left hand side equations of 1 and 2, it will be T minus m1g plus m2g minus t. So t gets cancelled, we will be having m1g minus m1g plus m2g. So taking g common, it will be m2 minus m1 into g. On the right hand side, adding this m1a plus m2a. So taking acceleration common, it will be m1 plus m2 in bracket into a. Here we need to find the acceleration, so take a as subject, take m1 plus m2. On the other side, we get m2 minus m1 upon m1 plus m2 into g. Now substitute the values of m1, m2 and g. We get 12 minus 8 upon 8 plus 12 into 10. That is A equals to 2 meter per second square. Now we need to find the tension as well. We got the value of the acceleration. Now in one of the equation we can substitute the value of A. Here using this equation 1, it is T minus m1g equals to m1a. Taking T as the subject and taking minus m1g on other side, we get m1g plus m1a. Here taking m1 common, it will be g plus a. Here m1 is 8, g that is 10, acceleration that is 2. So that will be 8 into 12, that is 96 Newton. So tension equals to 96 Newton. This is the shortest way for finding the tension. You can apply the acceleration value on any of the equation 1 or equation 2, and you will be getting the value of tension. So students, you may note down this numerical. Now numerical number 17. A nucleus is at rest in the laboratory frame of reference. Show that if it disintegrates into two smaller nuclei, the products must move in opposite directions. So initially the nucleus is at rest, so let its mass be m and velocity be 0. So we can consider that its initial momentum pi, which is equals to mv, equals to 0. Now after disintegration, it splits into two masses, m1 and m2, and they move in opposite direction. Let the velocity of mass m1 be v1, velocity of mass m2 be v2. So after collision, after disintegration, its velocity will be v1 and v2, mass will be m1 and m2. So the final momentum will be m1 into v1 plus m2 into v2. So pf equals to m1 v1 plus m2 v2. And by law of conservation of linear momentum, we know that initial momentum is equals to the final momentum. And here we have seen that initial momentum is 0, final momentum is m1 v1 plus m2 v2. Taking m1 v1 on the other side, we can write m2 v2 equals to minus m1 v1. Taking v2 as subject and taking m2 on the other side, we get m1 upon m2 into minus v1, that is minus m1 upon m2 into v1. These negative sign shows that velocity of both the fragments are in mutually opposite direction. So students, you may copy down this numerical.